Hello, it's Keith here, and this is lesson 40 of the platform-specific series of my 6502 assembly programming tutorials, and today we're going to be looking at the PET again. We're going to be learning about how to make some simple sounds on the PET. This isn't going to be a particularly long episode because there's not a lot of options there, and the ones that are pretty straightforward. So we're also going to have a quick look at Grime and YQuest, which can now work on the PET. So this is the last element of getting those games working. We've got simple graphics, we've got simple key input, and now we've got simple sound, so those games will work. Anyway, the PET itself, when it was shipped, didn't come with any kind of sound. There was no speaker built in. But there is an external I/O port, a data port, and you can connect a speaker to that, I believe. I don't actually own a PET, but the emulators do support that. Now, if we have a speaker connected in that way, we can control it using 3 memory mapped ports. The first is E8-4B, and this will define whether the sound is on or off, and we write a value of 16 to turn it on or 0 to turn it off. We then have an octave port, and there are 3 possible selections we can specify there, and each gives us a possible 2 octaves. These overlap, so the PET in total can do 4 octaves, and the 3 possible options we can send to that will give 2 different octaves each. So basically octave 0 and 1 can be achieved by writing a value of 15 to E8-4A, and octaves 1 and 2 can be achieved with a value of 51, and 2 and 3 can be achieved with a value of 85. So we can basically get all the possible octaves with a value of either 15 and 85 if we prefer. We don't need to use 51. And then we write a value to E8-4-8, which is the port that selects the tone, and the value should be between about 64 and 255, and that will select the pitch within the selected pair of octaves. Now, if we want legitimate notes, we would want to give the values, and you can see I've put a table of them here, which will give approximately the correct tones that you would want for an octave. Now, what I'm going to do in today's episode is we're going to make something. Now, what we're going to do in today's example is we're going to make something I call Chibi Sound, which takes a single byte parameter, and this allows us to make tones in a variety of pitches, which is what I used in YQuest and Grime. So let's go over and let's take a look, and you can see I've got a new toy above me just here. This is my oscilloscope, and we'll be using this to sort of hear and see what the sounds actually look like. So let's fire up Chibi Sound. Now, typically Chibi Sound would actually do noise effects and different volumes, but I don't believe those are really possible on the PET, and maybe you could achieve it with some very rapid and complex timing changes, but generally I don't think that's going to be possible. So you can see and hear here that as the numbers go down, the pitches are changing, and basically the way it works is that we pass a single byte to Chibi Sound. The top bit is a noise bit normally, which doesn't work in this case. The next bit is a volume bit, and the remaining 6 bits are the pitch, so you can hear. And you can see we've got a variety of pitches here. Okay, so you can hear there that basically we do indeed have a range of possible pitches, and now we're going to have a look at the actual code that has achieved that. So here is our code here, and what I'd suggest is if you're looking to make some sounds yourself, you could maybe use this as a template to get started. And so the first thing we're doing is we're either turning the sound on or off with port E8-4B, and to turn it on we write a value of 16, or to turn it off we write a value of 0, and that will turn the sound on or off. Now what we need to also do, of course, is select our octave range. Now the Chibi Sound only uses a total of 64 notes, and I found that for my purposes the value of 15 gave the best, so I'm just using the fixed octave selection of 15 here. We write that to E8-4A. Of course we could also use 51 and 85, and we'll try that in a moment just to hear the alternate sound ranges that are available. The final thing we need to do is pass a pitch. Now Chibi Sound uses 6 bits for the pitch, and we're actually shifting those to the left twice, and then we're sending that to port E8-4-8 there, which is selecting the note, and that's really all there is to it. As I say, I don't believe there's a way of changing the volumes on the PET or making particularly noise effects. We could of course add some randomization, but the noise effects Chibi Sound makes are usually quite distorted, so that wouldn't quite be what I had in mind when I wrote Chibi Sound. Anyway, let's turn the oscilloscope back on again, and let's try some of the alternate octaves and just see what difference that makes to our sound. So here is the default octave of 15 here. So that's starting at quite a low pitch there. Now if we change to our second octave, which is 51, and if we just run again, well, you can hear, of course, we're starting from a much higher tone there. And then finally, if we just try our last one of 85, and we just run again, well, obviously that's the highest pitch there. So we can do a variety of octaves and tones there. We've got a bit of variety there with regards to our sounds, and we can play simple tunes with this, and we will be looking at that later on. Currently a project I'm writing is called Chibi Sound Pro, which is the more extended version of this sound routine and allows for playing some music and things. So that is something we will look at in the future. Now, as I say, you're now able, if you go to my website and download the source code, you can get the new version of YQuest, which is not working here because my settings of my pet are wrong. If I go to pet settings here, we need to set it to 32K and run this again. The settings I've used, the memory layout does require 32K. So if we run again, there we go, that's it running correctly now. And it's not great. I mean, we're using graphics, we're using ASCII characters rather than proper sprites because we don't have any sprites, but the game does at least work, and you can see we can play it. The flashing things are the enemies there, and we've got to collect our diamonds as usual. But as I say, the point this was making was that the game can at least be ported to this system, even if the graphics are not there. So there we go. So that's YQuest now running on the pet there, and also we have Grime also running on a pet. Now I think I did see someone mention in my comments that apparently this game was based on a pet game or something, possibly. So that's a very surreal thought. I didn't know that when as I say, the first version of this I saw was on the MS-DOS machines. So I certainly didn't know that, but I've heard that said, so maybe that's true. Anyway, this is the game working. It works just the same as it does on any other system. The only difference is we're using ASCII characters now. And basically, what I've done is, in these cases, I think I've pretty much based it on the VIC code in a lot of ways. And rather than using, on the VIC we were using characters, but we were redefining those characters and using our own custom characters for bitmap graphics. But on the pet that isn't possible. So what I've done is I've created banks of graphics. So the Grime game has 2 frames of animation, so I've done 2 pairs of graphics characters for all 16 sprites here, and on YQuest there are a total of 4 banks, and so you can see here these are the characters that are being used by the game for each of the sprites, and there's 4 for each because there's 4 banks of animation there. So that's how I've ported these games. So anyway, there we go. That's all we're going to be covering today. A pretty short episode because, as I say, the sound on the pet is pretty simple, but I thought it was definitely worth having a look at. Now, one thing I would finally like to mention, just in case you don't know, is I have written a book on 6502 assembly. It's called Learn Multi-Platform Assembly with Chibi Sound, and it covers Z80, 6502, 68000, 8086, and ARM. So it's a beginner's book, but it's quick and to the point and tries to describe everything that you would need to get started in a simple way for beginners. It's available from Amazon now, and there'll be a link below in the description and the comments and things, so please take a look if you want to support my channel and hopefully learn a bit more about assembly at the same time. If you've liked what you've seen, please like and subscribe, because we've not done on the pet yet. We're going to be coming back to it and doing some more stuff, so hopefully you will see some more stuff that will interest you. And of course I've got other programming on lots of other systems already in the past and coming forward. I hope you've enjoyed this. Thanks for watching today, and goodbye.